Hey, how's it going everyone? This is I Am Error and I'm back with another tutorial on Unity. This video is part 2 in a series for UI elements. And in this video we'll discuss how we can fill out UI elements through code, as well as different tips and tricks on how to format different UI values, and how to manage your UI while using as little reference variables as possible. We'll be using the HUD that I made in the previous video as the template in which we'll be working with, but the practices in which I'm going to discuss in this video can be used for any type of UI, and in this video I'll show you how we can reference different sprites as images for UI, how to have a string variable reference as text for UI, and then add live game data to that string reference, and how to optimize a project by using an event system that'll notify scripts when an event has occurred, and then allow those other scripts to perform needed logic to update UI values only at the point in which they need to be updated. I'm going to include any script that I either made or updated for this video on my GitHub page, and I would recommend you download those scripts to go ahead and follow along with this video, but this video is going to cover some topics that should be able to translate to any type of project that you would be making, so using the exact logic that I have in this video isn't necessary to get the solution that you're probably looking for. Regardless, there's a link to my GitHub page in the description of this video. So without any further delays, let's go ahead and get started on this video. I have a very simple scene already set up. It contains a main camera game object with the camera follow script for the player. It contains the HUD that I made in my previous video, and since last video I've made and added a script to my HUD parent game object, which of course I'm going to be going over in this video. I have a simple game object acting as a ground platform that only contain a sprite render and box collider components. I also have this new level manager game object, and all this level manager game object is doing is instantiating the player into the scene just so I can provide a tip on how to reference game objects within the scene. I've also updated a script located on my player that'll call an event whenever the player takes damage or receives health so that the health bar can update when it needs to. I've also created another script for my player that I'm going to add to the child game object of my player that contains a sprite image as a reference of the player head, so that we can easily and automatically reference the sprite used as the player head, and then attach that sprite image to our UI. I'll be going over the player scripts first, because the HUD manager script is going to be using logic from other scripts, so let's just go ahead and knock out those other scripts first, so that it'll be easier to explain how the HUD manager script is working. In my project within the scripts folder, I created a new folder to house all my UI based scripts, and the first script I'm going to be discussing is the head sprite finder, and let me quickly explain how this script is going to work so that you understand what this script is doing, and if you need to make a similar script that's more appropriate for your project, you'll know what to name the script and where to place it. So I'm going to quickly open up the head sprite finder script and show you all the logic that it contains, which as you can see is absolutely nothing. How this script works in my project is I've added this script to the game object on my player that contains a sprite render component that houses the head image for the player, and then I simply add this script to that game object so that I can run a Unity method find object of type, and assuming I set up the project correctly and there's only one player in the scene, I can quickly reference the sprite render component located on the head game object of my player at start through my HUD manager script without needing any kind of direct reference of the player game object within the scene. So you can create these empty scripts for your project that you can add to different game objects within the scene to get a sprite reference of an image that you would need for your UI without having to manually reference that sprite or image. Now, going about referencing sprites this way through your UI will only work for that one type of sprite or image, because the way the find object of type method works is it returns the first reference of that object within the scene. So if you have more than one reference, it may or may not be the sprite or image reference that you need for that UI element. Moving right along, let's go ahead and talk about the level manager script next. This is going to be the most watered down version of a level manager script that you can possibly get. It's literally only going to contain a public game object reference of what the player is, and then it's simply going to run the instantiate method at awake and spawn the player into the scene in the same position and rotation as the level manager game object. We'll need to add an empty game object into the scene that'll act as the level manager game object, and then we'll attach the level manager script to the level manager game object, and then of course add the player as the public game object reference for player. Next, I want to quickly go over the health script that I have located on my player, and quickly show you how a delegate event system works. As mentioned, all the scripts used in this video are located on my GitHub page, and if you want to understand how this health script works a little bit better, check out one of my previous videos in which I go over how to manage player health and knockback force. A link to that video is located in the description, but in this video I'm only going to discuss what I've added to this script, and won't be going over anything in this script that was already discussed in a previous video. At the top of the script above the variables, I have my delegate event system written out. I don't want to go into the weeds and confuse you on the technicality of what a delegate event system is, and logically how the computer reads the code when we write everything out. So I'm going to explain how a delegate event system works in very layman's terms, and not spend any time on discussing how the code is actually read by a computer. Think of a delegate event system kind of like an alert notification for your phone, but instead of just telling you that something is happening, a delegate will go ahead and take action when that notification comes up. So how this often works in game dev is you'll have a script processing its own logic. The conditions for a logic make a notification true, and then at this point in the logic, this script will tell all the other scripts that listen or subscribe to this event, and then those scripts would process any additional logic that they would need to separate from each other. The benefit of using an event system is that none of the scripts need a reference to each other to subscribe or listen to an event, and one single event can be subscribed to or listened to by as many other scripts as you would want. A very popular use of an event system within game dev is what the game needs to do whenever the player receives damage. For the example with the HUD, I want the red portion of the health bar to deplete whenever the player takes damage, and then of course I want the red part to fill up whenever the player receives health. So first we create a delegate void, and basically what a delegate void is doing is it's setting up the parameters of the event. For most situations, a delegate void is going to be public because it needs to be received by other scripts, and a delegate void is also going to need its own unique name so that there's no confusion in the logic when other scripts subscribe to this event. If your delegate void requires specific information to properly run the logic, it's definitely a good idea to set up that parameter when you write out the delegate void, so that any script that needs to subscribe to this event will be receiving all the needed logic to flow that method. For the situation in this video with the HUD, the event is going to need to know an int value of what the current health is on the player, so we set up an int parameter for this delegate so that any method that subscribes to this event will be receiving some sort of int value. Whether or not it's the int value that the UI needs is a different story, but it'll help ensure that any method that runs whenever this event is called will be providing some sort of information needed in order to get accurate results. So after we create the delegate void, then we create the event, and to create the event we go ahead and reference the delegate void that we just made, and then give the event its own unique variable name. And for this example we made the event name the same name as the delegate void itself. Now that I've explained how a delegate and event system work, let's take a look at the new logic that I've added to this script. First I added an update method, and all the update method is doing is checking for input detection and running either the damage method or the heal method depending on which key is pressed. These input detections both check to see if the player is alive, and for the input detection that checks for the heal method, ensures that the player is not already at max health. Let's scroll down and take a look at the damage method. Within the method logic, right after current health is negated by damage amount, we now run the update health event, and we feed the event the parameter of current health. What this will do is let any script that subscribes to the update health event know that the event just occurred, and then gives those scripts the int parameter they would need to go ahead and run their logic. This will probably make a lot more sense when we take a look at the HUD manager script later this video, but before we do that I want to quickly discuss the heal method. The heal method is going to act very similarly to the damage method, but rather than negate current health by amount, this will go ahead and instead add amount to current health. It'll then go ahead and run the same update health event, feed it the same type of current health parameter, and then set up some bools within the animator script to allow the heal animation to both play and stop playing. Now let's go ahead and start discussing the HUD manager script and how we're going to use this script to fill out the different UI elements while manually setting up the bare amount of variables within the inspector. And the first thing I need to discuss is the different using statements that we need to add to this script. So let's take a look at the very top of this script right underneath where it says using Unity Engine. The first one we need to add is a reference to the different UI components that come with Unity, so we'll need to add the Unity Engine.UI using statement to make sure that we can reference the needed components on the UI system. The second using statement that I added to this script, the system using statement, will allow us to access a basic .NET feature so that we can easily round a decimal point. So this second using statement is purely optional, but I definitely want to show you my favorite way to round to a decimal point because I almost never see this way posted on a Unity forum. A lot of the variables that I have within the HUD manager script are references to different game objects found within the HUD game object itself, and if you wanted to fully automate your HUD and require absolutely no manual setup through the Unity inspector, just like we did for the head sprite finder script, you can create different similar finder scripts for your different UI elements and not have to manually plug in references like I'm about to show you here. But typically with something like a HUD, you can make a prefab out of that UI system, and because usually all the different components of a HUD are made up as children game objects of a HUD parent, you typically only only need to set up a HUD manually once, and then from there you would have a one-size-fits-all prefab that you can use for different player game objects. So it's really up to you how you want to reference the different children game objects on your UI. I just want to show you all the different and most common options through this video. The first variable is a reference to the image component on the HUD, and this image component is going to be where the player head sprite is going to be placed on the HUD. Next, we have a reference to the slider component that houses the health bar, and we use the slider value to fill up the red portion of the health bar, which we're going to translate as the player current health. Next, we have a reference to the text component on the HUD. The text value of this text component is going to be a string reference that we set up within the inspector, as well as a float value of how much time has passed since the scene started. Next, we have a string variable, and we'll fill out the value of this string within the inspector window. First, I want to say all the different public variables that we have here can be public if you want. I made them private because of good code practices, but I still want to set up these private variables within the inspector. So anytime you add serialized field to a private or protected variable, that'll allow you to fill out that variable within the inspector window. But not setting up a private or protected variable through code will trigger a cautionary error within Unity that is only reminding you that you never set up a value for this variable. And to avoid seeing that cautionary error, if you don't plan on setting up any value through code and only want to set it up through the inspector, then you need to give it a value of null through code, and that'll prevent Unity from triggering that cautionary error. Moving right along with the variables, the next variable is going to be a float value of how fast the health bar needs to update when there's a new value. A lower value will mean the slider for the health bar will update slower, and of course a higher value will make the slider update its value faster. I give it a generic value of 0.5f here in the code, but we can always override this value within the inspector window if we want, but for me I found 0.5 is a good speed in which it needs to update the UI. Next, we have another float value for time till fill. This value is going to be a t value for alert method. Basically, what that means is this value is going to be something between 0 and 1 to have the health bar update dynamically between the current slider value and what the UI shows, and the actual current health value located on the player. On that note, we have a separate float value of current health for the HUD, and this value is going to be what the current slider value shows, and increment the red image on the health bar between the current value and the new value that it needs to update to. So to transition between the value that's currently being shown on the HUD and the value that it needs to transition to, we have this separate float value called new health value that'll tell the slider component on the HUD the actual current value of the player health and what it needs to increment to, whether that be up or down. We go ahead and hardcode a value of 100 for new health value right off the bat, and this is because the way the current health system is set up for the player, the current health value at the start of the scene is always 100, which for a lot of games probably won't be the case every time you load a new scene, and typically I manage the current health value between scenes through a player pref, and rather than automatically making both of those values max health value at start, I would set both of those values as that player pref that I have set up. However, I don't have time to explain how player prefs work within this video, so I just want to let you know I have this new health value set up as 100 here just for testing purposes, and depending on what type of game you're making, the new health value should equal whatever the current player health value is at start. And then the last variable we'll have is this private float variable for time and level, which I'll be feeding this float value as an additional string value to the time text message string, so that the time text message will first contain a custom string value that you set up in the inspector, and then that string reference will end with the real float value of how long the game has been running since start. Now that I've described how all the variables work, let's go ahead and quickly take a look at the methods in the HUD Manager script. We first run a start method. What this start method is actually doing is it's first going to set up a reference for all the different finder scripts you have in the scene, and for this video the only finder script is located on the player to locate the player head sprite. But if you had other items that you would need a reference through a finder script, such as different UI screens that you would go ahead and reference at start, then you would go ahead and add all those other different references here in the start method as well. Right now the image component on the HUD has no reference to the player head sprite, so we want the image component to look at every game object within the scene and find the first game object that contains a script for head sprite finder. Then we reference a sprite renderer component that's hopefully located on that game object, and use the same sprite that we have for that sprite renderer component, which for the example that I'm providing in this video is the player head sprite located on the player, and then feed that sprite image as a sprite reference the image component needs, so that it can display the player head in the HUD rather than the white square. The next thing we do in the script within the start method is subscribe to the update health event found within the health script, and what we have to do to subscribe to this event is have a method within this HUD manager script that has the same type of parameters as the update health delegate does, which if you remember from earlier this video is an int value, and the HUD manager script does contain a method that requires an int parameter through the change value method. I'm going to go over this method here shortly, but this is how you would subscribe to an event within Unity. Now keep in mind you don't have to subscribe to an event at start. Most of the time I use delegates, I do subscribe at start, but of course there may be situations that come up in which you would want a method to subscribe to an event at a different time other than start. Beneath the start method, we have an update method. And real quick, I made all the methods within this solution private. You can make them public if you want. There's really no harm in doing that. But I really want to show you how you can set up UI independently without having to directly reference many things. And to prove that point, I made each method private just to show off that you don't need any direct reference to have consistent data between different scripts. But the update method is going to be running two different methods. First, the add time method, which is simply going to be updating the time and level float value to how much time has passed since the level started. This value, along with the time text message string value, will be fed as the text values located in the text component for the HUD so that it always has an accurate representation of how much time has passed. So let's quickly take a look at the add time method to go over it. The first thing this method is going to do is check to make sure that the current health value is greater than 0, because if the current health value is less than 0, then this would mean that the player is dead and that we're likely in a game over situation, so we don't need to keep adding any more time to the time and level value. Assuming that the player is still alive, we then add the amount of time since last frame to the time and level float value, and then we set up the text value in the time text component as first a string value of time text message, which again, we're going to set up time text message within the inspector window, and then we have this addition sign, which lets the time text.text value know that there's additional string values that need to be added to that string reference, and the value that we're going to be adding is the time and level value, which of course is a float value that could have a fairly long decimal point that we wouldn't want all those decimal values for. So what I'd like to do is have the time and level value rounded to the second decimal point, and then we add that time and level float value with 2 decimal points to whatever the string reference value is for time text message, so that the HUD has the custom string message first, and then after the custom string message, we go ahead and feed it the exact value of time and level with 2 decimal points rounded off. Let's pretend you want to have the time and level value rounded to the third decimal point. Then you would replace this 2 within the parentheses for the math.round part with the 3 instead of 2. This math.round method does require the using system using statement, so if you want to have this functionality with rounding off a decimal point, make sure you have that using system using statement at the top of your script. The second method within the update method is the new bar value method, and this method is going to go ahead and update the UI by lerping between 2 different values, the current health value and the new health value, and then increment the UI based on those values. The first thing it's going to do is check to see if the current health value doesn't equal the new health value within this script. The new health value for the HUD manager script is going to be updated every time the update health event is called, so the HUD manager new health value will go ahead and receive the health script's current health value whenever that update health event is called. Once this new bar value method sees there's a difference between current health value and new health value, it'll go ahead and increment the slider value on the HUD based on the new health value. This method will go ahead and lerp that value between its current value and the new value it needs to go to, and animate that value in the UI through the slider component. If you don't understand how lerping works, it's outside of the scope of this video, so I won't discuss any further on how this method is actually working within this script. We do have one last method within the HUD manager script that we've touched base on a couple times now, the change value method, and this change value method is going to run automatically every time the update health event is called. As you can see, all this change value method is doing is updating the new health value to the parameter amount value for this method. And if you remember, the parameter int value for the update health delegate was the current health value on the health script. The change value method is also resetting the time till fill value back to 0, so that the lerp method and the new bar value method can run as it should. Now that I've discussed all the scripts and how they work within this solution, let me show you how we would set up the HUD manager variables within the inspector window, and then of course playtest the solution. So go ahead and save the scripts if you need to. Let's go back into Unity and take a look at the Canvas HUD game object. Let's expand the Canvas HUD game object and take a look at the HUD parent game object. Add the HUD manager script to the HUD parent game object. The first variable is an image variable, so if we expand the children of the player icon parent game object, the last child game object is the player head image game object. This child game object does contain an image component, so let's go ahead and drag the player head image game object into the slot for player head image. The next variable is a slider component variable, and if we take a look at the health bar parent game object, it contains a slider component. So let's go ahead and drag the health bar parent game object into the slot for health bar amount. The next variable is a text component variable. If we expand the children game objects for text timer icon parent, we'll see the time text game object does contain a text component. So let's go ahead and drag the time text game object into the slot for time text on the HUD parent. Next, we have an empty string variable, and we want this string variable to say something like time and then have the time value after the string variable. So I'm going to type out time, colon, and then add a space. And this will be the string value that I have for time text message, which will then be fed to the time text game object. It'll then go ahead and change the value of the text box within the text component. And the way we have the code set up is it'll display the string reference value that we just put in the inspector window now first, and then it'll display the actual amount of time that's passed since the level started based on that private float value time and level in the HUD manager script. And this will make a lot more sense once we playtest, but let me quickly talk about this last variable first on the HUD manager script, and then I'll show you how all this looks. The last value we have on the HUD manager script is the slider fill speed. We've already set this value up through code, but if you want to make it a custom value, you can go ahead and change that value here. I don't actually want to change the value from what it is in the code already, so I'm going to plug in the same value that I already have set up in code. There's a couple really quick things I need to do before we playtest, so bear with me. But because we're instantiating the player through code from the level manager script, on the level manager game object in the scene, I need to make sure I have a player prefab loaded in that slot for the player game object. So I'm going to go ahead and drag my player prefab from my project window into that slot for the level manager game object. And I already went over this at the start of this video, but I also need to make sure that the head game object on my player has a head sprite finder script on it. So go ahead and add that if yours doesn't already have that. And just to prove that we're actually going to be updating the health bar through code at start, I'm going to change the slider value on the health bar parent game object to 0, so that the UI for the health bar appears empty at start and will actually fill up through code as I want it to. But assuming you have everything set up correctly, let's hit play and test it out. And right off the bat, you should notice all the UI elements fill out automatically. The player head icon automatically fills up in the right slot. The time value has our custom string message as well as how much time has passed since the level started, and then the health bar automatically fills up to the full amount. Now if I hit T and take damage, the health bar updates and is negated by the damage amount. If I press H to heal, the health bar updates by the heal amount. If I click on the HUD parent game object and change the string reference and time text message, you'll see it updates the custom message live through the UI, but it still has the correct amount of time that's passed since the scene started. So I hope this makes a little bit more sense on how we could have a custom string message with actual data from the game in that string. Alright, that'll go ahead and wrap up this episode. If I was able to teach you something new, you found this video useful for beginners, or if you were just generally entertained by the video, please consider liking the video and subscribing to the channel if you're not already subscribed. One last thing before I go, if you use the information in this video to make a Metroidvania style game, consider taking a look at my course on Udemy, Metroidvania Toolkit. It's one of Udemy's highest rated Unity courses, and is currently listed as one of their best sellers. In the description of this video, there's a link to my website that contains a coupon for the course, so take a look at my website to get the best price on the course. But that's enough self-promotion for one video. I definitely appreciate you taking the time to watch the entire video, and hope to see you in a future one. Hope you all have a great rest of your day, and take care, y'all.